Hi, welcome to Zona Mechanica. Hope you are enjoying our videos. If it is really helpful to you, please do share with your friends. And if you are new to our channel, please do subscribe it. There is an MCQ on stress in a gear tooth. Figure at the margin indicates the weightage of the question, that is 2 marks. A spar gear has a module of 3 mm, number of teeth 16, a face width of 36 mm, and a pressure angle of 20 degrees. It is transmitting a power of 3 kilowatt at 20 revolutions per second. Taking a velocity factor of 1.5 and a form factor of 0.3, the stress in the gear tooth is about. There are 4 options given. Well, let me write down what are the data given. Module M is 3 mm, number of teeth T or Z is 16. Okay, face width B is 36 mm, and a pressure angle, okay, phi is given 20 degrees. Okay, power transmitted is 3 kilowatt, and the speed is given 20 revolutions per second, and the velocity factor CV is 1.5, and the form factor Y is 0.3. Since the factor is given, so the stress asked to find out maybe the static stress, that is sigma 0. Okay, allowable static load sigma 0, and it is related with the working stress by the velocity factor. Sigma working is equal to sigma 0 multiplied by the velocity factor CV. Okay, let me draw a schematic diagram. Suppose this is a tooth of the gear, and this is the face width B, and this is the tooth thickness. And if the normal load is acting like this, this is a line tangent to the base circle. Okay, and suppose the normal load Wn is acting like this, then the two component is the vertical component Wr will be acting like this, and the horizontal component, that is the bending load or tangential load Wt, will be working like this, right? See, this vertical component will create some compressive stress which is very small in comparison to the tangential load, so we can ignore this one in the design of the gear. Okay, so this is the main load, which is known as the beam strength of the gear tooth, right? So this is considered in the calculation of the stress. Okay, so we know that the Wt is equal to sigma working multiplied by B pi m into y. See, this is the working stress. Okay, already I told here, and this B is the face width and pi, and this is m is the module. Okay, module, and y is the form factor. Okay, so clearly we can substitute this sigma 0 multiplied by CV multiplied by B pi into m into y. So now how to calculate this Wt? Okay, we shall get this Wt from this power transmitted. Okay, P. See, we know that P is equal to torque multiplied by the angular velocity omega, right? So which is equal to the force Ft or Wt. See, this Wt multiplied by the radius, that is the pitch circle radius, right, is the torque. Okay, so Wt multiplied by the radius, pitch circle radius, okay, Rp multiplied by omega. Okay, so again, omega we know. See, this is speed n is given, so we can write 2 pi into n, right, rad per second. So from here we can get this Wt. Therefore Wt will be equal to P by this Rp multiplied by 2 pi multiplied by n, so which is equal to 3 multiplied by kilowatt, so we shall take in watt, divided by Rp. Now the pitch circle radius, see, we know the module m is equal to d by t, right, r by t. So from here r is equal to mt by 2. Okay, okay, so m is 3 multiplied by 16, sorry, m, this t is nothing but z. Okay, z instead of t I am writing z. Okay, mz, okay, mz by 2, 3 multiplied by 16 by 2, so which is equal to 24. Okay, so r is 24 and this is in millimeters. Okay, so multiplied by 10 to the power minus 3 and 2 pi multiplied by n is 20. Okay, so this will give 994.718 Newton. Okay, so now this Wt is equal to sigma 0 into, so from here sigma 0 multiplied by Cv b pi m y is equal to 994.718, which implies sigma 0 will be equal to 994.718 divided by Cv is 1.5, b is 36 multiplied by 10 to the power minus 3 in meters. Okay, and or else we can keep in millimeters, so that directly we shall get Newton per square millimeters. Okay, okay, b and pi and module in 3 mm. Okay, multiplied by y, form factor 0.3. Okay, so clearly this is in Newton and this is in millimeters, so square millimeters, so Newton per square millimeters, right? So this will give some 6.51 MPa. So this is the stress asked to find out here. Okay, see, this is not matching with any of the options given. Okay, whatever it is, this is the process we can calculate the stress, either working stress. If it is told to find the working stress, directly we shall put this formula if the Cv is not given, but in this case Cv is given, so maybe they are asking this sigma 0, so we have calculated sigma 0. So this is the process actually. Hope you have understood the process.